Welcome to Spring LIB.
Okay, in this question, we can divide the acceleration into two components. One is the tangential acceleration, which is the length of the rod times the angular acceleration. And the other component is the radial acceleration, which is the length times angular speed squared. The tangential is always in the same direction of the velocity, and the radial is always from the object to the center. So in situation A, in the beginning, so the angular speed is 0, so the radial component is 0. So we only have tangential acceleration. So the acceleration is perpendicular to the rod. And the force on the object, we have tension and we have weight. So we know that the acceleration is equal to tangential acceleration in this situation, which is, so this angle is G, this angle is theta. So this angle is also theta. So this is equal to mg. So the tangential acceleration is going to be G sine theta, right? So in the second situation, now besides the tangential acceleration, you also have the radial acceleration because the angular velocity is not 0. So the total acceleration can be the sum of these two. So tangential acceleration is perpendicular to the rod. Radial is along the rod. So the net acceleration is gonna go a little bit up to this direction. And again, this is tension, this is weight. The last question. Okay. So here we have weight, right? So we also have tension going up, right? So from question A, you can know that the tangential acceleration is G times sine theta. In situation 3, the theta is 0. So the tangential acceleration is G sine 0. 0 is just 0, right? So only radial acceleration left. So the total acceleration is going to be a radial acceleration in this situation. So how can we know what's the velocity at this moment? We can use energy conservation. So in this process, in question A, you only have potential energy. So now in question 3, you only have kinetic energy, which comes from the potential energy in question A, right? So here, so this distance is L cosine theta. This distance here is L, right? So the height difference is going to be L 1 minus cosine theta. So the weight, this is mgh, which is a potential change, then equal to half mv squared, right? This is kinetic energy. So the change of potential energy equal to the kinetic energy, which will give us the potential energy equal to square root 2gl 1 minus cosine theta. M and M get canceled here.